Welcome to our playlist, in which we have taken many questions to prove identities using mathematical induction method. Enjoy the journey of learning with Anil Kumar. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we have taken an excellent question from IBHL test series. We need to prove using mathematical induction that sum of 4 to the power of r minus 1 from r equals to 1 to n is equal to 4 to the power of n minus 1 divided by 3 for all n positive integers where n is greater than equal to 1. You can always pause the video, answer the question, and then look into my suggestions. We'll go from basics and also understand what is mathematical induction while proving this particular identity. In case you want to learn from me, feel free to send an email on globalmathinstitute@gmail.com. We are taking students. Great. Let me also thank all the viewers and subscribers for watching my videos, posting excellent comments, and contributions. With your contributions, your channel is being able to provide you with free solutions, absolutely free solutions for the last 15 years. Now, with 17,000 plus videos, these videos are being watched over 80 countries. Keep contributing so that we can reach millions. Thanks for your support. Now, let's get back to the question. Here, we have to use the method of mathematical induction to show that sum of this series 4 to the power of r minus 1 is equal to 4 to the power of n minus 1 over 3 when r is from 1 to n. Is that clear to you? So there are n terms in this series which when added should give you 4 to the power of n minus 1 divided by 3. Great. So two things, one sigma notation, it really means the sum of all the numbers, right? And before that, in mathematical induction, we follow three steps. Step one is we have to show that when n equals to 1, the identity is true. So let's do that part first. So that means we have to add all the numbers when r equals to 1 to 1. That means just 4 to the power of 1 minus 1, correct? And this is, as you know, is 4 to the power of 0, which is indeed 1. So this is our left hand side, correct? Let's see the right hand side. On the right hand side, we have 4 to the power of 1 minus 1 over 3. And that is 4 minus 1 over 3. And that is also equal to 3 over 3, which is 1, correct? So we have shown that for n equals to 1, left hand side equals to right hand side. So that works, correct? Now we will do an assumption, right? And the assumption is that this identity also works for n equals to k is true. That is to say that sum of all these terms for r equals to 1 to k, which will be 4 to the power of k minus 1, is equal to 4 to the power of k minus 1 divided by 3. This is true. So that becomes your step 2, right? This is your step 2. And step number 3 is to show that it works for k plus 1 also, right? That it works for n equals to k plus 1, right? This is what we need to prove. And that is, in short, that the sum from r equals to 1 to k plus 1, it will be 4 to the power of k plus 1 minus 1, right? That should be equal to 4 to the power of k plus 1 minus 1 over 3. Make sense? Correct. That is what we need to prove. Once we prove that, in that case, we say that this identity has been proven using the method of induction. So I hope the method is absolutely clear to you, right? Now let's see how do we really prove it, correct? So let's begin uh, to prove it. So we already know that. So our assumption was what? Assumption was that for k n equals to k, it works, right? Is true. This was our assumption. So that is to say that this sum of r equals to 1 to k, 4 to the power of k minus 1, is equal to 4 to the power of k minus 1 over 3. Correct? Now, what happens when I do k plus 1, right? If I do k plus 1, I get this term as sum r equals to 1 to k plus 1, 4 to the power of k plus 1 minus 1, right? Now, what is this equal to, right? I could rewrite this as, in sigma notation, r equals to 1 to k, right? To the term 4 to the power of r minus 1, right? Plus 4 to the power of k, right? Now we know that the right hand side is equal to what? We can take it to this side and then continue our work. So this is equal to, we can write this as r equals to 1 to k plus 4 to the power of r minus 1. Let me rewrite this. Plus 4 to the power of k. You know this sigma we already have seen that is equals to 4 to the power of k minus 1 over 3. Correct? And we have to add 4 to the power of k to it. Taking common denominator, which is 3, we get 4 to the power of k minus 1 plus 3 times 4 to the power of k. Is that clear to you? Now, 3 plus 1 is 4. So this is also equal to 4 to the power of 4 times 4 to the power of k minus 1 over 3. Correct? And that can be written as 4 to the power of k plus 1. Correct? Minus 1 over 3. And that is what we needed to show. Correct? So that is what we wanted to show. So clearly, this is equal to the right hand side expected, correct? Because if this is true for 4 to the power of k plus 1, then in that case, we wanted to show that for sigma r equals to 1 to k plus 1, 4 to the power of r minus 1 is equal to 4 to the power of n being replaced by k plus 1, right? Minus 1 over 3. And that is what we have got. Do you see that? So once we have shown that this is equal to the expected result, we say by the method of induction, we have actually proven this identity. Is that clear to you? So that is how it can be done so easily. So I feel that now it's absolutely clear how do we use the method of induction to prove such identities. Let me thank all of you once again for your support. In case you want to learn from us, feel free to send an email on globalmathinstitute@gmail.com and keep supporting. Thanks a lot. All the best.